This next section, dealing with least common multiples, is probably one of the most important sections of this entire course because it lays a foundation for a lot of things still to come. Now, least common multiple, we usually abbreviate that with the letters LCM. Then that's not to be confused with the GCF, the greatest common factor that we're going to be dealing with later. So the set of directions usually say, find the least common multiple of two numbers. And so I'm going to write down the least common multiple of 12 and 15. I want the smallest thing, that's the least part, that they both go into. The both part is the word common, multiple, numbers they both go into. Now there are a few different methods for finding this. I'm going to begin with method number 1, the listing method. That's where you take a look at the number 12 and the number 15 and you list out each of their multiples. So with 12, you say 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 48, 12 times 5 is 60, 12 times 6 is 72, and you can keep on going with a listing of multiples. The word multiple says that's got that word multiply in it that helps you remember that you're finding numbers that are bigger. Then with 15, you multiply 15 times 1 to get 15, 15 times 2 to get 30, 15 times 3 to get 45, 15 times 4 gets you to 60. And aha, we've got 60 showing up on both lists. That is a common multiple of both the 12 and the 15, and it's the least one because it's the first one that shows up on both of these listing of multiples. Now, this is kind of an easy method, but if you get off and you don't know your multiplication tables and you're going 12, 24, 36, but then you say, oh, 46 accidentally, and you get off by a little bit, that really messes up the whole system. So it's got its drawbacks, especially if the least common multiple is very large, like 450. Now, a second method for finding the least common multiple is to divide out prime factors. So what we can do is we can write the numbers 12 and 15 side by side, and we can ask what goes into each of them, what prime number. We're never going to divide by 1, and we notice that 3 goes into each of these. 3 goes into 12 4 times, 3 goes into 15 5 times. And I want to keep breaking down prime factors. There is no number that goes into both 4 and 5, so what we're going to do now is we would take the 3, the 4, and the 5, we would multiply them together to get 60 that way. Now, that gets a little bit challenging when you have larger numbers, and I need to show you a couple extra little details that goes with this second method. Let's say we're finding the least common multiple of numbers 36 and 60, each of which have a lot of common factors. Let's begin by dividing 2 out of each of these. 2 goes into the 36 18 times, 2 goes into 60 30 times. Now each of these are still even. Let's divide them each by 2. 2 goes into 18 9 times, 2 goes into 30 15 times. Now 2 does not go into either 9 and 15, but 3 does, so let's divide by 3. We're now going to have 3 and 5, which have no factors in common, and so we can multiply these numbers along the edges of the bottom together. 2 times 2 is 4, times 3 is 12, times 3 is 36, times 5 is 180. Now that might not be the way you'd want to multiply them together, so maybe you'd take the 2 and the 5 multiply together to get 10. 2 times 3 times 3 is 18, and then go 18 times 10 to get the 180. You don't have to multiply in exactly that order. Now let's find the least common multiple of 3 numbers. And I don't want to go with the listing method. I like this second method I've shown you the best. So I'm going to write 18, 20, and 28 out here. And I'm going to divide out the common factor of 2. Always divide out prime numbers, and that will be more successful for you. 2 goes into 18 9 times. 2 goes into 20 10 times. 2 goes into 28 14 times. Now, I can't divide a common factor out of all three of these, but 10 and 14 are both even numbers. So let's divide a 2 out of both the 10 and the 14, giving me 5 and 7. Now, since 2 did not divide into 9, I'm just going to bring that 9 right on down. 9 is not a prime number. I'm going to divide out 3. I don't have to. I can just multiply these numbers along the edges here. But if we want to get the prime factors out of this, there's my 3 times 3 makes 9. And I'm just going to bring the 5 and the 7 down that way. Now we can multiply the factors along the edges. 2 times 2 times 3 times 3 times 5 times 7. I'm going to take the 2 times 5 times 7. That's going to make 10 times 7. That's going to make 70. And 2 times 3 times 3 is 18. There's 18 times 70. And I'm just going to go off to the side and do that. 18 times 70. I'm going to put my 0 down as a placeholder. 7 times 8 is 56. There's the 6. Carry the 5. 7 times 1 is 7. Plus that 5 is 12. So this time our least common multiple is 1,260. A little bit large. Not one we'd want to do by the listing method. Let's say we want to determine which of these two numbers is larger. We know that 5 is more than half of 8. And 7 is more than half of 12. So it's a little bit harder to tell in a quick glance which one of these two is larger. In order to make a comparison, we must have a common denominator. So we look at this 8 and we look at this 12 and we see what is their least common multiple. What do they both go into? And it turns out they both go into 24. So I'm going to rewrite each of these fractions over 24. Now to go from 8 to 24, that denominator was multiplied by 3. So I'm going to multiply 3 times 24, but also 3 times 5 in the numerator. Notice when I'm multiplying by 3 over 3, I'm really multiplying by 1. So 5/8 times 1 is still 5/8. This will be an equivalent fraction. 3 times 5 is 15, and 15 over 24 is equivalent to 5/8. Likewise, over here at the right, to go from a denominator of 12 to 24, we're multiplying by 2 in the denominator, and we need to multiply by 2 in the numerator to get 14. Now we can see when we compare these over a common denominator that 15 parts out of 24 is larger than 14 parts out of 24, so we would put a greater than symbol there. But that can be carried up and used to fill in that box up on the top. Let's say we are asked to write these fractions in order from smallest to largest, from least to greatest. In order to be able to order these, we really need to compare them over a common denominator. What do 6, 4, 2, and 3 all go into? What is their least common multiple? Well, it turns out that it's 12. So I'm going to rewrite each of these over 12. Now, to convert them to be over this least common denominator, or least common multiple as a denominator, we look at the 6, the old denominator, and we determine that it's been multiplied by 2 to get to the 12. So we're going to multiply both the numerator and denominator by 2 and write that as 2/12. Likewise, with 1/4, 4 times 3 makes 12, so this fraction can be multiplied by 3 over 3, and we would have 3/12. In the next fraction, 2 goes into 12 6 times, so we're going to multiply both the numerator and the denominator by 6 to get 6/12. And then finally, 3 goes into 12 4 times, and that last fraction will be multiplied by 4/4, giving us 4 over 12. Now that we have these all over the same denominator, we can compare the numerators and say, these are almost in order if we reverse or switch the order of the third and the fourth term. Now we're being asked to write these original fractions in order from least to greatest, not these converted ones. So we would say that our solution here is going to be 1/6, 1/4, 1/3, then followed by 1/2. Anytime you need to order fractions from smallest to largest, or from largest to smallest for that matter, you need to have them over a common denominator in order to be able to make that comparison.